Hi, my name is Ashley Sinnett, and I am the Purification Specialist in GMP HPLC at Integrated DNA Technologies. In GMP, we synthesize, purify, and formulate oligonucleotides that are typically used for diagnostic purposes. And so those are things like cancer screenings for detecting diseases or illnesses. And one of the ways that that is done is by PCR. And PCR, or qPCR, is really typical, which stands for quantitative polymerase chain reaction. And so we make the primers and the probes for that. Primers are short DNA or RNA sequences that serve as a starting point for DNA synthesis. And probes are fluorescently labeled DNA sequences, and they're designed to send out a fluorescent signal in the reaction. And so the entire reaction is where I will show you that green ladder there, which is probably what you're guessing, that's DNA. Your PCR primer is at the very beginning, and that little blue guy that looks like Pac-Man is that polymerase. And so what he does is he comes through and he is making copies of each strand, and he makes his way over to that little guy that says dye quencher right here. That is the probe. And then once he makes his way through, he breaks that probe, and you can see that the dye and the quencher break apart from each other, and then you have free-floating dye within your sample. And that free-floating dye is read at a certain wavelength, and so within this process, a target DNA is being amplified, or it's making millions and millions and millions of copies. And as you can imagine, when you have millions and millions of copies and that much fluorescence within your sample, it's gonna make a change, if you will. And there are very special instruments that read at that wavelength, and they can see that fluorescence. And then if it's there and it's really bright, that means that somebody is probably positive for what they're looking for. And if it's really, really dull, or if there's no light at all, then that means that somebody is technically negative for what it is they're looking for. And it's a super, super cool process that we help make. If you are interested in learning more, feel free to reach out. I personally didn't foresee myself at a biotechnology company. I started off as a microbiology major. That is what my undergrad degree is in. But you are allowed to change your mind. You can start doing one thing and you can do something completely different. That is not wrong. It is okay to try different things out. That is the whole point of doing this, and it's to learn more about different fields and different careers. Along with that, I would highly, highly recommend that you reach out to the mentors and to ask them questions and to probe them and ask them more about their careers, what it is they like about their career, what it is they don't like, what they wish they could change, do they wish they did something different, or really just anything. There's so many things that you can ask. And I would be more than happy to talk about it. It's really, really exciting to me. Science is something that is really, really exciting to me. And I will also say IDT also offers daily tours. So if you are so inclined, please come and see us and come say hi. Of course, that is when the pandemic has tapered off and people are no longer in quarantine and you can stop social distancing. Until then, keep social distancing. And then you can ask us more about, I don't know, different things that we're helping with, like certain pandemics, maybe. I can provide articles of where IDT has been mentioned, and some messages from our president, Trey Martin, and some of the things that he said about IDT and what IDT has done to help not just in the US, but people around the world. So On that note, again, please feel free to contact me. I would be more than happy to answer questions with whatever it is you might be interested in, whether it is microbiology or if it is biotechnology and DNA, whatever it is, whatever sparks your interest. Please feel free to reach out. So, yay!